7. And if we press new session, all values will be reset to default. And that's the interface. And now, after you have booted the ADU in the field, the first thing you should do is checking the self-test result. So we go to System Status and Self-test, and we should see that mostly the ADB error should be 0.
Yes, and all the fields should be green.
And if one of the ADB is orange, it may be that maybe one channel is overpowered. That should be ADB error number 41.
Yep.
Yeah.
In this case, the field is yellow. This is not a critical error, it's just a warning that you must take care and read the messages that are further down the page.
So, but basically it should be green, and if there is any other error than 41, you should have a look into the manual in order to find the error description. Some messages will also be here appear.
Yeah.
With a short abbreviation, and mostly it should show then signal to high, or
yeah. Or if you don't have any electrodes connected, you will see that the probe resistance is too high, something like this.
Yeah. So in our case, which is here in the laboratory, the probe resistance is quite low.
It's almost 0 for the electric fields. It's quite high for the coil channels because the coils are overpowered in our lab.
Yeah. So below we see the suggested gain settings for different modes of recording.
Yep.
And if you would manually supply the gains, which is not recommended, you should the app let decide, you would try to use these settings.
Yes. For example, here we see directly for the electric field channels where we have very low amplitude, the ADU suggests very high gains. For the channels where the coils are connected and we have these huge amplitudes because it's overpowered in our lab, the MVU suggests very small gains.
Yeah. So in the field you should normally use not more than 4, even higher gains are suggested, but 4 is always good, and also you should try to reach 4. Anything else is not desirable. Only if the ADU in the field says gain 1 should be 1. In this case you should not try to set to 4, because then you easily have maybe high DC offset or other problems, so the ADU will run into trouble if you force to set a higher gain setting than shown here. That's okay so far? Okay.
It's okay, yeah.
So we can now configure the ADU and go to the channel section, and there you see the sensors which are connected. So if you should see MFS 6 and no serial numbers, your coils are likely not connected.
Yes. And if you connected the coils before you boot up the ADU and use the new session button, you must see the coil type and the coil serial numbers in this dialog.
Yeah. So here we can use autogain, auto offset.
Yes. So you can simply activate the boards you want to record data on. And then you can click on the Use Autogain Auto Offset button, and it will directly enter all the values that have been determined by the ADU as suggested values for gains, and use it for the measurement that would be started with the web interface, now in this case.
Mm-hmm. So, and as I told you, 4 or 8 should not be exceeded. Sometimes you get this HTTP error, don't care about that. And these settings are automatically saved. No? So now What is next? We should go to the sensor positions. I think so.
Yes, if your electrode distance is different from the default or from the last settings that you used, you should now enter the correct values for the E-field spacing.
Okay, so then normally, because your cable is 50 meters, you should go minus 50 for south and 50 for north, for example. And the same is for the west, you take 50, and for east, you take then also 50. That would be a 100-meter E-field layout.
Yeah.
Okay, so detect sensors is possible, but if you have to press the button because the numbers do not appear here, you can check, you can try, but at the end, when you finalized your settings, you should reboot the ADU in order to get the correct settings for the gains as we have applied here earlier. So it may be that after booting you get a more reasonable value of 4, for example, and these values are only available after you have made a reboot using the normal self-test. And the self-test configuration is here. And self-test configuration, and by default the standard self-test is activated.
Yes.
And Martin, what does it carry out? It carries out for sure the sensor detection, but also the probe.
It determines the probe resistance on the E-field electrodes, and also tries to determine the best fitting gains for your site. So depending on the noise at the site, depending on the E-field spacing and the amplitude on the inputs coming from the sensors.
Okay. So anything else? At this moment I think we are finished with configuration. So we have set the sensors, we have set the electric field spacing, so we can start to submit a job.
I would, before I start a job, quickly have a check on the GPS.
Yeah.
Now in our case we see we are fully synchronized. So we are even fully synchronized to any other ADU system that is also G4 fix, and as a result you will have synchronized time series that can be processed together.
Mm-hmm.
If you start a measurement, for example, with the GPS status being no fix, it's not sure that the ADUs will record synchronized time series. So there may be a difference between the two systems.
And I think we have to wait until G4 fix, because when the ADU starts recording, it will not switch the state anymore.
No, as long as the recording is active, the ADU will not resynchronize to the GPS signal, even if the GPS board gets a full sync during the runtime of the job. This is simply to avoid any jumps in time during a running measurement.
Yeah. We also see that we have connected only one battery, and voltage is good, 13 volts. And we also can see that is here. And because we are now connected, the amperage is 1 amp, but it will drop down to 0.7 or 6 if the ADU goes to sleep mode.
Yeah.
No? And we also see that the SD card is almost free, so we have 28 gigabytes free. This message we see when the ADU was shut down and reboot. This has no meaning. You can clear the error list before you start recording. That's fine. So then let's program a job. Maybe we configure first the site. I think we can go to the general page, for example, and if you have some site information, this will later appear in your EDI file. So if the site is, for example, line 1, site 23, this will later appear in your EDI file. No? And you can give a remote site for default station, for example, for remote reference processing. The software may use this information in order to find a remote reference station automatically if you have one which is maybe 30 or 60 kilometers away. and the others you can fill, it's not so important. The only thing which is important to let later the software process automatically and find a suitable processing, you can give a name here, and the best name is MT-Auto. This can be changed later after you have done your recordings, but the ProgMT software will search for a configuration called MT-Auto. Okay, so
And now as we configured the channels, so we selected the boards, configured the gains, everything is okay. So we check the sensor spacing, everything is okay and entered. We check the GPS status. Now we can finally start a measurement. And so the easiest you can do, if you just want to make a quick test, you just select the desired sampling frequency, for example 65 kilohertz. And by default the length of the job is always half an hour, unless you enter something else. If you would now press the Start Now button, the job would start immediately. This is very simple for testing. If you want to have a defined starting time and defined stop time, you need to enter those values in these fields and click on the Submit button. Now just to show it, I will just start the job now.
Yeah, like maybe make it shorter. Okay.
And we can stop at any time. And take a check, and now we see the job will start within the next seconds from now.
So we can submit also multiple jobs.
Yeah.
And this has to be done one by one. No? So if I now program the next job and the next job and the next job, I do this subsequently. So let me show something. So is recording now, and when we go now to the hard disk, also to the flash drive, we can see that when we log in and see that the recording has started, and we can see on the flash drive that the data is now increasing. We have now programmed for half an hour. That would be quite a huge job. However, it's possible to stop the recording anytime, which we can here do on the Stop Job button.
Yep.
And then finish, stop this job. And in a few seconds we will see that the recording will finish. So go to System Status, no jobs are scheduled, selftest is finished, and takes a while. Finished. No? So at higher frequencies, all buffers have to be flushed, so it takes some seconds until the ADU goes back into idle state.
And the data is written to disk. Yeah.